Good afternoon.
Afternoon.
Hello, everyone. Afternoon, Farah. Right, so this week is week 6, right? Lecture, we're supposed to start on chapter 9, switch security configuration, right? Um, just a little bit left on the chapter 8 that I want to um, look at, okay? But before we go to that, right? So, security configuration. After a few slides on the land security, we're going to switch over to this chapter 9. And chapter 9, we're going to divide into two sections. So this today, we're going to look at the first part, and then tomorrow, second part. Right, so I want to remind you guys also that you know that this week I'm going to post the details later in our Google Classroom. This week, tomorrow, um, basically same time as last week, we're going to have a dry run for SBA, right? So if you recall, SBA is skill-based assessment. So it's the second assessment from our coursework, right? So we have two assessment, right? One is the one that's concluded last week, which is the test, and the second one is the practical test. Oh, so last week was written test. This week will be, sorry, the second one will be practical test. This week, we'll just do a dry run tomorrow, right? Same time as before the dry run. Okay, I will um, post all the details later. Right? So just make yourself available from 5 o'clock, 5 o'clock, right? Now, the actual SBA, the skill-based assessment, will be conducted next week, and at the same time, which is Tuesday, around 5 o'clock, right? We start now, right? So, um, if you have any packet tracer that you're still working on, I'm afraid you have to um, try to complete them, right? Because a lot of the um, configuration, okay, will be from your packet tracer. So the examples will be there, right? Also, if you are doing your practical and you have questions, right? This week's practical will be last chance for you to ask in terms of when we really have more time to cover it. Yeah, if you've encountered any issues, difficulties with the packet tracer exercises that we've been doing, right? Um, Try to ask them within this week, because next week we will have the actual SVA, right? Which is week 7. So there's not much time already, right? So I also want to remind you guys that as part of your um, NetAcad learning, yeah, we will conduct the NetAcad online exam, right? Towards the end of week 7, right? So during the weekend, I propose that you guys, so you have enough time to also practice on that. Yeah. So next week, during the weekend, I will open it uh, during the entire weekend. So from maybe midnight or evening Friday until midnight of Sunday. So like before, when you did the previous course, right? If you um, pass you can I think can about try about 3 times, right? If I'm not mistaken. I think you went through it, I didn't conduct with you, but I think the lecturer, I think Dr. Tan, she's doing the tutorial, or is it our lecturer from KL? Okay, uh, let you try. Is it? If you get the like 75, I'm not sure. I will double check for this session. You will get another one of the certificate, right? And this will continue until your next network course, which is advanced computer network, right? So you'll be able to have opportunity to collect your certificate, yeah, from Cisco. All right. Okay. So let's get on with this week's lecture. So I'm gonna just show you guys the topics, right? Okay. So the topics that we're going to just cover a little bit, yeah. Just a reminder before we actually uh, do the next chapter. So the next chapter is basically configuration you can do on your switches to mitigate all these attacks. So previously we looked at the different types of LAN attack. Okay, so just let's have a look at this ARP spoofing, positioning, SDP, and CDP reconnaissance, yeah, and see what they are. All right, so I'll start with just allow you guys to have a quick uh, video, right? So I'm gonna share, and I'm gonna mute my mic so you guys can have a look at the video, short video.
Address Resolution Protocol is a powerful protocol on our networks that allow our networks to function. With ARP, we're talking about having a known IP address being mapped to an unknown MAC address. And this is being used all the time with our devices on a network. Now, a client can send an unsolicited ARP reply, which is known as a gratuitous ARP. It's really a broadcast that we have a specific IP address that is mapped to a specific MAC address. Now, the problem is when someone sends out a gratuitous ARP as a broadcast, other devices, which should be hosts as well as network switches, are going to store that MAC address and IP address combo in their ARP tables and MAC address tables. This is an issue because a threat actor can send a gratuitous ARP message with spoofed information inside of it. This effectively allows any host to claim to be the owner of any IP address and MAC address combo that they want to. So let's talk about it. Here in our graphic, we've got PC1, PC2, and R1. They all have ARP caches that are up to date and correct. But what's going to happen here is PC2, the threat actor, is going to send out a gratuitous ARP. And that gratuitous ARP is going to claim that 10001, the IP address of the router, is reachable by using MAC address all Cs, which is the MAC address of the threat actor. Also, the threat actor PC2 sends out a gratuitous ARP claiming that 10011, which is the IP address of PC1, is reachable with MAC address all Cs, which is again the attacker. So what's going to happen here is when PC1 sends data to the 10001 IP address, it'll be sending it at layer 2 to the attacker, which is all Cs. When the attacker receives this data, it'll be using it as a man-in-the-middle attack. When the router responds to 10011, the router will be responding to the layer 2 target, the MAC address of all Cs, which again is going to be the threat actor. So what it comes down to is exactly this. PC1 will want to send data to 10001, and to do so, it'll send it to the MAC address of all Cs, which is PC2. PC2 forwards that data onto the router. The router will send it outbound to where it needs to go. As the router responds back to that 10011 IP address, it'll be responding back targeting all Cs, again the MAC address of the threat actor. This is a beautiful man-in-the-middle attack. Spanning tree is a protocol that is on by default on our Cisco switches. Its job is to provide us redundant connections while maintaining loop-free pathways, and it does it great. But the problem is threat actors can utilize spanning tree to actually change the topology of your network infrastructure. Now, the way they would do this is based off of logical, not based off of physical connections, but they would make their host appear as a root bridge. To do this, they would be sending out bridge protocol data units, which are spanning tree layer 2 messages, and these messages will include a priority of something insanely low, such as 0, for example, here in our graphic. By sending out these spanning tree messages saying that their priority is insanely good, the network infrastructure will view that threat actor's host, which is pretending to be a switch, as the root bridge, and they will all find the best way to reach the root bridge, which means they'll be dropping their main connection between each other and connecting through that switch itself. This allows the threat actor machine to pretty much act as a man-in-the-middle style attack and to be able to see all network traffic moving across this network domain. Cisco Discovery Protocol is a Cisco proprietary Layer 2 link discovery protocol. This thing is amazing. It can be used to verify Layer 1 and Layer 2 connectivity. And the cool thing is it's on by default on all Cisco devices. Now, on that same point, it can be insanely scary that it's on by default on all devices because it's used to automatically discover other CDP-enabled devices that are directly connected. This can even be used to auto-configure some of their connections. Now, while CDP is extremely useful in network troubleshooting, our threat actors can use it to easily discover network infrastructure vulnerabilities. For example, the CDP information that's being sent out, it's being sent out periodically and as unencrypted broadcasts. This information that is periodically sent out and sent out in an unencrypted format includes the IP address of the Cisco device. It includes the Cisco Internet Networking Operating System version. It includes the platform, and even based off of the capabilities of that model of the device. It even includes VLAN information and more. So here's a graphic that pulled off of a protocol analyzer showing a CDP message and ripping it apart in this unencrypted, unsafe protocol reaching out to our end devices. So how can we stop our end devices from receiving this periodic unencrypted CDP laden full of info of greatness? Well, 2 commands. We have no CDP run. No CDP run is put in the global config mode of your device, and that will turn off CDP everywhere on your Cisco device. Or you want to leave CDP on for those inter-network device connections between Cisco devices, but just off on the user interfaces. That would be the command no CDP enable. That's in interface config mode, and that's what you use on your interfaces connected down to end devices. We also have LLDP, which is Link Layer Discovery Protocol. It's a ventral neutral flavor of CDP. This is also vulnerable to recon attacks. We can turn this off globally in our global configuration mode using the no LLDP run command. As well as if you want to do interface specific commands, we can use no LLDP transmit and also no LLDP receive, respectively.
Oh,
All right, so there you have it, right? So ARP, STP, and CDP reconnaissance. Right, so we all already seen basically the 2 services, the ARP, STP, and basically we can't live without it, yeah, right? If we don't have ARP and STP, okay, so for ARP, we're not able to get the MAC address, and for LAN, MAC address is very important, right? MAC address is used to forward frames within a LAN because IP is just to identify the PC, but for the actual forwarding of frames, we use MAC address. So we are vulnerable to spoofing and poisoning attack, right? Now the STP, right? So for having an efficient LAN, okay, especially a large LAN where we want to scale up our LAN size, yeah, we sometimes want to provide redundancy, especially when we also have critical network requirement, which means it cannot be down, yeah. So redundancy allows loop, okay, loop inside the network, which is bad, right? We saw earlier in the semester, the loops cause broadcast storm, right? And that can bring down the network very, very quickly. So we have a STA running as STP to prevent loops while providing our redundancy path, right? But again, as you saw in the video, STP is vulnerable to attack as well. And both the ARP and STP, uh, attack by using man-in-the-middle attack. That means a threat actor can place themselves in the middle of the communication and basically provide false information, right? False information to disrupt the correct functioning of ARP and STP, right? And then this can happen without the end devices or hosts inside the LAN to know that there's been an attack because it's man in the middle. You can't sometimes you can't differentiate between whether the fake ARP STP is actually an attack on the system, right? Because you're not actually doing any harm or damage, but just listening in, manipulating the protocol, the way it works, yeah, in order to listen in. And the main point is to capture traffic, right? The main point here is that the traffic is redirected so that the threat actor's machine or host device will be able to capture those traffic and therefore view the content of the traffic, right? So you saw that one example of a protocol analyzer is the something called Wireshark. Okay, Wireshark is a application that's free to download, right? And it's very, very good for troubleshooting your network. But one of the other things it can do is to go through all the layer, okay, the OSI layer, the TCP/IP layer, and basically view the content of the PDUs. So if your PDUs are not encrypted and most traffics are not encrypted, the threat actor will be able to find a lot of details about your network in order to maybe perpetrate a more advanced attacking, right? CDP basically is very useful also for troubleshooting and also to understand your network topology, right? Maybe if you guys have ever tried topology, real-time topology viewer, all right, where the software is able to uh, create and detect and learn about your topology so that it can show the topology to you, right? So which means the software will be able to map out how many switches you got, how many hosts, what are their addresses and things like that. So in the application that you can download, there are some of them are free, right? You basically can see in graphical format, okay, the topology of your network, and this is very useful for system admin. Okay, in combination with that, you can also see once the topology is viewable, you can actually see the performance or the status of each of your devices, right? Whether it's online, offline. So in terms of troubleshooting and monitoring, this this CDP is very good because it tells you what's happening with your network. But because it can provide you all the detailed info about your topology, right? For the system administrator, because the system administrator basically has the authority to view all this, right? Whereas a threat actor can use this info to learn, right, in detail about the topology. This again will help the threat actor to devise further further methods, further ways to to back into your network lah, right? Right. So let's have a look at very briefly at ARP attacks. We already know what ARP does. ARP basically is address resolution protocol. Okay. The key point here is the resolution, meaning all the hosts, right? They have ARP cache, including the router, yeah, for the interface, have ARP cache. ARP cache start empty, right? And using ARP service, the host can then dynamically populate the ARP table. And why is the ARP table important? Because I mentioned before, ARP keeps a map of MAC address to IP address. Okay, at the application layer level, when our application wants to communicate with a remote host within the same LAN, right? It will use the IP address. Okay, and we are used to using IP address. Okay, but in the LAN, IP address is not actually used by the switch to forward frames. The switch works with MAC address. So ARP is required if the host machine do not know the MAC address of the remote host that you want to communicate with, because you only know the IP address and your ARP cache doesn't have the entry. So you have to send broadcast message, okay, hoping that the target or destination machine will reply the ARP message, right? The reply will contain the destination MAC address, therefore allowing the sender to send the frame. Okay, so ARP attack basically is there are two, spoofing and poisoning, right? So both is a man-in-the-middle attack, basically faking, okay, faking the information of the destination host, okay, pretending to be making it so that the information received by the host that sends out the ARP request uh, to provide fake information. Okay, so instead of the real or actual destination machine providing its own MAC address, it will be replaced by the threat actor's machine's MAC address. So thereby, after the sender's ARP table has the new entry is actually the wrong entry, because the MAC address stored there to map with the IP address is not the MAC address of the intended destination machine. So what is the MAC address there? Well, the MAC address will be the MAC address of the threat actor, right? So after that, every messages that being or frames that's been sent out intended for the actual destination host will go to the threat actor's machine set, right? So this is the main concept lah. So what happens after that? Well, the threat actor will get all the frames, thereby the threat actor can then use a protocol analyzer application, right? Example Wireshark, to view the content, the content of the frames, right? It's not supposed to look at it, but then again, got no choice, because the sender doesn't know that the MAC address provided to it was actually fake, right? So I'll just show you uh, this software. This is the software that you can actually use in a LAN to view, okay, to view once you get other host messages, you can then view the message inside, right? So you can see let me just give an example. Look at images on Wireshark, right? So you can see here some sample images. So if you run Wireshark, what you'll see is you start capturing, yeah, you'll start to get all the frames, right? So and you can then dig deeper. Once you select one of the frame, you can view all the layers, yeah. Okay, necessarily only the frame layer 2. You can also view layer 3, then layer 4, and then up all the way up to application layer, right? So application layer contain the user's information, right? So if there was any unencrypted messages, right, you'll be able to view it, right? You'll be able to view it, right? So this is basically very similar to what you get when you're doing similar to mode in packet tracer, where you can go inside and check it out, right? And the thing is, this is just the software that we have, right? Someone can write more advanced protocol analyzer where it can actually piece together all the messages, right? And having a search feature and things like that, right? So combination of these tools allow the basically user to the threat actor to get someone else's message and view it lah, right? And sometimes depending on what we send, could include secret information, right? Secret information, password, username, things like that, right? Okay, so let's go back to here. All right, right. So spoofing basically is faking it, lah. Faking those MAC address. That's why it's called spoofing. It's pretending to be something that's not, right? So basically pretending that it is the threat actor's machine is pretending to be the machine, the target machine, by by providing the you know its own MAC address rather than the intended machine's MAC address. So you can see here can be mitigated by implementing IP source guard, okay, IPSG, and the further details on that is on the next chapter. I'm going to look at the mitigation app, what we can do on our switches, right? Right, STP. Okay, spanning tree protocol is implementation of spanning tree algorithm, as I mentioned before, to allow us to have redundancy but still avoid loops, right? So basically, because a host machine, a proper PC, can uh, include all the layers of the TCP/IP protocol, right? So it can pretend to, well, using a software, you can pretend to be a switch, right? And when you pretend to be a switch, you can also provide the some of protocols that is used by spanning tree protocol. Okay, that means you can manipulate the election. Remember that in STP, the way the switches all right cooperate in order to detect who becomes which of the switch becomes a root bridge and which port becomes the root port, and then and so on, right? There's an election going on. Okay, normally there will be no problems lah, right? And in fact, the network administrator can also influence the election by providing private priority number. Okay, so in a typical situation, this allow the network administrator to configure the topology exactly how the network administrator wants the topology to be by influencing the priority number. But the threat actor can also use the priority number to basically uh, do an STP attack by setting up a fake switch whereby it's the threat actor's machine becomes a switch, right? Pretending to become a switch and then providing a very low, that means high priority number. Then it will force an election. All the switches will then redo the election, and of course, the threat actors will be the winner, right? And what happens if the threat actor machine becomes the winner, becomes the root breach? All traffic will go through that threat actor's machine, right? So this is basically the STP attack. Again, we can mitigate lah. We can mitigate this by implementing the BPDU guard. The BPDU is the protocol that we used to inside our election between the switches, right? So since attacker machine needs to connect to the switch anyway, so we implement the BPDU guard on the access ports. Remember that access, there are two types of ports, right? Trunk and access, whereby trunk is between switches, access is between switch and a host. So if a threat actor is trying to emulate a switch, right, in order to do this STP attack, it needs to connect, right, connect the switch. By implementing a BPDU guard on the access ports, all access ports, means you are basically preventing any machine belonging to a threat actor to attempt to do this STP attack. All right. So again, the configuration to mitigate this will be discussed in the next chapter, right? The switch security, right? All right. So just all right. So CDP.
Address resolution
Oops, sorry.
protocol is a powerful.
Let me just show you. Right. So I'm gonna show you something. One example, but this one is annotated already. So, but it's sort of an example of what we are talking about, right? Um, Let me just share you the screen. So here is a typical example. But well, sometimes we do have um, uh, um, a better software. But what happens when you run a software that can employ LLDP or CDP? They are the discovery protocol. Means what? Discover all the devices inside your network, thereby it, want to discover all the information that the software is able to display, right? Display the topology of your topology yourself using the CDP or LDP. The software is able to view, right? Have an overview and looks like, right? Not only that, all the related details about each of the devices is able to be discovered, right? So and at the same time, you can then have a map of your or map topology map of your network. Then you can activate certain protocol like the SNMP, Simple Network Monitoring Protocol, that you can then view individual devices and see their up status or whether they're online, offline, things like that, their IP address and so forth. Now, this is not only very important to the network administrator because they can view and monitor the network at the any time. But imagine this information is available to the threat actor. Okay, then they will have very valuable information about, you know, because the first step in order to attack a network is to actually know the topology of the network, what is available in the network, how is it connected, right? All the necessary details like IP address for each devices, how many switches do you have, how many hosts, things like that, right? So the threat actor having this will be able to plan the attack in much greater detail and effective, right? So again, it's a tool, just a tool, and the tool can be used for good and bad, right? So the thing is, with CDP, it's very convenient, LLDP as well, for the network administrator, but it's also convenient for the threat actor, right? So this is just an example of what you can view using a software when once you have this type of protocol running, your software will be able to simply just detect your topology, right? All right, so let me just stop sharing this one. Go back to our slide now, right? So what we want to understand here is the kind of protocol or services available in our network, which is actually very convenient, right? For the betterment of our network, but it can be repurposed, right? Repurposed by threat actor for a different purpose lah, not for the good of your network, but for planning an attack or simply stealing information, right? Right. So to mitigate, just now we already mentioned saw the example is to if you know if you already have a topology of your network, you don't really need to know your network topology all the time, right? Okay, so maybe you have a static version since your network doesn't really change so much, right? And whenever you change, then you change back your topology. So you always, or as a network administrator, you always know your topology. So there's no need to keep running CDP all the time. Maybe you run it one time to get the topology to find out, or when you need. That means ad hoc. You don't have to run it all the time. So when you're not needing it, right? So you can switch it off, right? So if you switch it off by doing the command no CDP run, right? Now, if you want your devices to only talk between themselves, the intermediate devices, okay, the infrastructure devices like switches and routers, but you don't because threat actor normally operates on the end devices. Okay, so you might want to disable only on the end devices, right? So the second command can be used, no CDP enable interface, right? Now LLDP is similar to CDP actually, right? I think Windows is using um, LLDP. Now Cisco is using CDP, but you can have both running at the same time, uh, and they do not interfere with each other, but they provide the same or similar service. Okay, the LLDP link layer discovery protocol. If you look under your network interface card protocols, what are protocols running inside your Windows machine, you can see that you can see this link layer discovery protocol shown in as part of the protocols that's running for your network interface card, right? So this is same. You can also mitigate the exploitation of LLDP by doing the same thing, by configuring your interface so that maybe you disable LLDP, right? You can disable transmit and receive, thereby stopping LLDP so that threat actor cannot use it, cannot piggyback on that information to gather info about your network, right? All right. So any question on that?
No.
No.
Okay. You guys no question. So I will stop recording first, right? Because I don't want to mix the recording, so it's easier for you to what lah. And then I start to record again after I change our slide, yeah, because we basically we reached the end already just now, right? And Now we move on to the chapter 9, right? Chapter 9, where what can we do to mitigate? So basically, a lot of the mitigation is depend on configuring on the switches. Okay, what we already checked earlier on. Let me just share my screen, right? Start recording. Okay, so yeah, chapter 9, module 11, switch security configuration. What you can do on the switches, what configuration you can do on the switches to mitigate all the attacks we mentioned in the previous chapter, right? So let's look at the title topics. Um, all right, so we categorize all the attacks different depending on the service that are being attacked. So um, since threat actor needs to connect their host machine, their device onto the network via the switch. So you will see that a lot of the configuration is done at that access port, right? Right. So the first topic we're going to learn is how to implement port security. Okay. So this mitigate MAC address table attack, right? Whereby we don't want them, the threat actor to provide false MAC address, whereby the MAC address table will be incorrect. This MAC address table is inside the switch, right? And then we also saw that a threat actor is able to hop between VLANs, right? So hopping between VLANs mean able to send receive message between VLANs are supposed to be in two separate networks. Okay, and usually we allow the traffic via configuring router, right? But as you can see previously, an attacker can actually use the double tagging as an example to confuse the the switch, so that is able to send a message from one VLAN to another VLAN. So the second topic is to mitigate these VLAN attacks, right? So we have to configure the DTP and a native VLAN, right? Remember the native VLAN also was used, yeah, the DTP based tagging attack, right? And DHCP is basically uh, exhausting, right? It's some form of denial of service, right? In the case that the threat actor wants to exhaust the pool of available IP address, which is supposed to be provided or leased by the DHCP server, right? And this is for, if you recall, DHCP server is a service that provides leases of a range of IP address, okay, to machines or hosts that wants to use IP address, okay, right? Of course, we don't have this problem if we use static address, but there's a lot of cases where um, we, through convenience, like example, wireless network, we don't want to manually set the IP address and other information. We want the host to request from the DHCP, and DHCP list the IP address and also provide other uh, information, right? But again, an actor can exhaust, okay, attack the DHCP by asking, by providing fake requests, right? By changing MAC address, rotating or and randomizing MAC address, DHCP server will not know those are fake requests. So the DHCP server will just simply give list out the IP address. Okay, so the IP address is now list to all of them. Is list to the threat actor machine. In fact, the threat actor not really use it, just want to exhaust the available IP address. What will this cause? This cause the other host, the legitimate host, to not have any more IP address because simply it's exhausted, right? All the IP address is used up. Okay, the DHCP server don't know because it's a legitimate request. It's a legitimate protocol, but it was requested by a threat actor instead of a legitimate host. Okay, so it's a form of denial of service attack. In this case, the service is the provision of IP address. Okay, and the last two, mitigating ARP attacks and STP attack, is one that we have mentioned earlier on, right? Before we finish up the chapter 8. Okay, so we can see here the example mitigation. Okay, so DHCP is we want to configure DHCP snooping, right? And then for ARP attack, ARP inspection, right? And then for STP attack, port fast and BPDU guard. In fact, port fast and BPDU guard, we already know how to set it, right? We learn it when we're on the STP chapter. It's just that we did not elaborate, okay, why we just say that, oh, okay, for security reason, but we didn't previously we didn't say what is the STP attack. But now we've gone through what is the STP attacks, so now we know the exact reason why we have to set port fast and BPDU guard, right? It's actually to mitigate STP attack. Right, so let's go to the first one, which is the implementation of port security, right? Right. So here is just an introduction. It says that layer 2 attacks are actually very easy for the hackers to deploy, right? As you can see earlier on, uh, it's, and it's not really very hard to write the software to 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 do this layer 2 attacks, right? But fortunately, the security the network administrator can deploy is not also hard because um, as a lot of these are actually built into the switches, and you can then configure some of this solution, right? So it says there the easiest way is to prevent access to the network, right? Here it mentioned all switch ports uh, interface should be secured before the switch is deployed. That means deployed here means the switch is live used by the network, right? So what do we mean by secure? Well, secure basically, you as an administrator, you know how many hosts is going to connect to the switch. Physically, you need to maybe probably you're the network administrator, so you have technician to do it for you. Okay, but usually you know which cable plug into which port, right? How many ports need to be available to connect to hosts because you design the network or you are maintaining the network. That means you also know which ports are not supposed to be used. So the ports that are not supposed to be used, okay, needs to be shut down. Simply don't allow um, any traffic to go through it. That means even if someone are able to plug in a cable into those ports, since those ports are in shutdown mode, is disabled, then plugging doesn't bring any benefit to the attacker, right? And in order for the attacker to shut down that port, they need to be able to access the command line interface of that switch. And hopefully you already provide password and provide encrypt the password. So that will block unauthorized access to the switch configuration, right? So just shut down all ports that are not being used, right? And because it's a simple method to bring it up again, you just type no shutdown for that particular interface, that particular port. Right now to configure, if you because sometimes you want to configure the Cisco switch basically have lots of ports. For your convenience, you can use interface range so to quickly shut down multiple ports. right? So instead of going to each interface and typing no shutdown, you can just use interface range, right? And then provide your port number range, right? Okay. So this is how you secure unused ports. Very simple but very effective, right? The next mitigation is mitigating the MAC address table attack. Remember, MAC address table attack simply means that you you know that the MAC address table it is going to be stored during operation, right? It's going to be stored in RAM, and RAM is limited. Thereby, the storage, that means the size of the MAC address table is also limited. So very quickly, if you are attacking the switch, you can um, take up the entire space, right, provided for the MAC address table, right, until it becomes what we say overflow. That means just like a glass, right? The glass where you pour water until you cannot pour water anymore. It just overflows, right? The water cannot go in anymore. So it's the same. No? MAC address table, since it's stored in RAM of the switch, it has a limited or finite size. So basically, to overflow it, basically just keep entering new entries into it, right? Flood it with fake MAC addresses until the switch fill up the entire table and then overflow. When it's overflow, that's the thing. The key thing is the attacker just want to make the switch overflow, right? Because once it's overflowed, the switch will um, change into broadcast mode, right? And when broadcast mode means uh, any messages will be broadcasted. Any frame going into the switch will be broadcast to the egress ports. So in this way, again, the attacker will be able to get all the hosts in the in the networks, right? Frames, okay, so that they can do whatever they want to the frame, so they can view each side, right? So this is the MAC address table attack. So we want to mitigate it, right? And how we do that is to enable port security. So port security basically limits the number of valid MAC addresses allowed on a port, right? So because if an attacker wants to fill up the or to overflow the MAC address table of a switch, it just simply send frames, and these frames have different MAC address, different MAC address, different MAC address, right? Different MAC address means if the switch check inside its MAC address table and it cannot, uh, it doesn't have that entry for that MAC address. The sender's MAC address is not recognized, not inside the table, so it will add that MAC address in. Keep adding, keep adding. But if you set port security to limit the number of valid MAC address allowed on a port, right, then this will mitigate it. Basically, the switch will reject other, depending on how many MAC address you allow, right? If you allow one, after it detect the first and insert an entry, the first MAC address, then subsequent MAC address it will just reject, right? Now, as a network administrator, you know this port belongs to which machine, right? So if you only allow that particular machine to connect to that particular port, then you can set the limit to one valid MAC address, right? Or two, maybe you also allow that employee, okay, or the person who's using that port to maybe time to time maybe plug in the other machine. So maybe you left it to two, okay. Um, Two fake entries will not overflow, right? So you as a system administrator or network administrator, you can decide how many valid MAC address per port you want to allow. All right? Is that okay for this one?
Okay.
Yeah. All right. So
Can limit to not just one only. Uh, can still two or three.
yeah, you can still allow. It's up to you. The minimum you can allow is one, basically. But you can go all the way up to how many you want, because again, you can decide lah, because you are the network administrator.
Okay.
Okay, yeah. So sometimes, like use case like for me, maybe I bring my laptop and I don't want to use the Wi-Fi. Okay, I want to use my laptop. So maybe sometimes I plug in my desktop. Maybe sometimes I plug in wired um my 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 laptop lah, basically, right? So yeah, maybe then I will ask request two, okay, to MAC address my main machine and my laptop, for example. Yeah, right. And it will mitigate. Why? Because the way it works is that the threat actor has to send many frames, every frame with different MAC address, and thereby the switch will keep adding those MAC address, okay, into the MAC address table until it overflows, right? Okay, by limiting, that means the threat actor cannot do that anymore, because after two, then it will just reject, right? Um, okay. So port security is enabled by this command: switch port security, right? So you have to select your interface first, and then for that interface, you can then type this command: switch port security, right? So here is a case where that command you put can be rejected, right? Because you can only configure port security if you're using if you already configured the access port, right? As manually configured access port or manually configured trunk port. Means you are the one who configured that port as an access port or trunk ports. Then you can uh, configure port security. If the port is configured dynamically, so for example, trunking, right? You can use a desired auto, things like that. Then the switch port security cannot be enabled. It will be rejected, right? If you want to use switch port security, make sure those ports you have configured manually lah, either access port or trunk ports, right? That's the only caveat, right? It doesn't work if the port was set dynamically, right? Especially trunk ports, right? So you have to manually lah. If you want trunk ports, you set it manually, then you can then put port security. So, so the command is there. Right. So how you verify? You use this command: show port security interface. Right. So it shows you here, and then the highlighted ones or the ones in red are the ones that you want to um, look out for lah. That means because it's got lists of info, so these are the important ones, right? Basically, maximum MAC address is the one that we said you specify as the value. What is the maximum? More than one, then it will be rejected. But then that is also configurable. As you can see, violation mode. What happens if this is violated? You can specify to shut down. Shut down means immediately that port is unusable because it's shut down. No more connection, right? So it's quite good lah. That means the moment the switch detected that from that particular port there are more. To be honest, there shouldn't be more than, if you set at one and only one machine or one host is supposed to be connected to that port, there shouldn't be more than one MAC address detected from that port, right? Because your MAC address is unique, you should not have a MAC address that keep changing, right? Does it make sense to you guys?
Oh yeah.
That is, yeah, the MAC address of your machine should not change, right? Because it's supposed to be burned in into your NIC, correct? So it's perfectly logical for you to set the maximum MAC address for that port is 1, right? Because if you just use one machine, one port, right? Disregarding our example just now, maybe you want to use laptop. Let's say we don't, not allowed. Just your machine to that port, right? It shouldn't be more than one MAC address detected for the port. Should be sufficient, right? Because your MAC address doesn't change, should not change because it's actually burnt in. It's supposed to be unique, right? So you can specify if that is violated, what happens. Or here, the violation mode is shut down. So basically the switch, if it detects a different MAC address suddenly from coming from that port, where it's already recorded initially an address, a MAC address, suddenly you detect, hey, this one is different. What will the reaction of the switch will be to shut down that port. Okay, this is if you configure that way, right? Okay, right. So you can see error disabled state shut down, but the log will show error disabled state. Right. So after you enable port security, then you can configure what type of port security attributes you want to set. So by typing the question mark after port security, you can see other options you can set, which is aging, the MAC address that's allowed, a maximum secure addresses, and what is the violation mode? Violation mode basically is that one. Shut down. And you can specify. Right. So limit and learn MAC addresses, set maximum number of MAC address allowed. By default, it's 1 because shouldn't be more than 1 usually. Right? Right. The maximum value you can put is 8,192 lah. But you must be wondering why, unless that port is a public port, right? That port is a public port. It may be Starbucks where people can come in and plug in, right? So maybe yes, you might reach 8,000 after if you don't switch off your switch or reset your switch for many days, many weeks, right? The different number of MAC address detected from that port. If that port is a public port, it means, and sometimes you want to connect without Wi-Fi. Sometimes you want to use port. Example, last time, I just give you an example. Last time, because why maybe you don't want to use Wi-Fi, sometimes it's because you want security, the more secure, right? Wi-Fi is not secure. So you want to use, if you use wired, it's more secure, isn't it? Yeah. So also you want stability in the network connection. Wi-Fi, if too many people try to connect to Wi-Fi and then you find that Wi-Fi performance go down lah, right? But wired is different. Once you plug in, you're guaranteed that until the switch your um, your traffic is belong to you only, no sharing, right? So yeah, it could be possible that you can reach maybe 8,000. Okay, if you don't reset your switch, your switch been learning from that particular port. But of course, your network when it's allowed public to go in, you already know that you're not supposed to put in any secret information in that network, right? What about other users? Well, other users is meant to be educated. If you're using public network, even wireless or wired, right? You shouldn't. You should be very careful, right? But example, the maximum is up to 8,192, right? But in a typical organization, because the machine is the desktop machine, right? The PC is already allocated to an employee. The employee not going to move the machine around, right? So it's okay to have default of 1. So what happens when it's default to 1? Then if there's any attempt to plug in another machine with a different MAC address, then yes, the port will shut down. But since the machine in a machine, right, in a PC, you can actually type your own MAC address, right? So that's a potential what lah. That means you can emulate the port and port MAC address for that particular port. But you still cannot do the overflow attack lah, right? Because in order to do overflow attack, you have to keep on sending and forwarding frames with different MAC address through the same port, and it will be detected, right? All right. Okay, so switch can be configured to learn about MAC address on that secure port in any one of these 3 ways. So there are 3 ways: manually configured, dynamically learn, dash sticky. So all 3, you can choose one. Okay, there are 3 options, but you usually choose one, and you have to use one of it. Manually configured means you as the administrator, you need to know the machine that is connected to the port, so you have access to it. So you have access to what is the MAC address of that particular machine. Then you can manually configure the port, yeah, to specify what is the secure MAC address for that port. Right, any other port MAC address will be rejected, and then it will activate the what happens lah, whether it shut down or something, right? Sometimes you don't shut down, but you generate a log error, okay, so that the administrator is alerted. Okay, hey, hang on, that particular port on the switch, something happened there, right? So it's just trigger, but there's no shutdown. But you can also shut down and trigger the log, right? Directly learn means when you entered the switch port security command, immediately when the switch learn about the current source MAC address for that device, okay, then it will, if it's not there already, no entry, it will straight away secure, right? Means it will detect that MAC address is the secure MAC address for that particular port, for that particular machine connected to that port. But it's only for that particular session, right? That means it's not added to the running config, and also it's not stored in the as permanent, right? So if you somehow reboot the switch, then it will forget about that dynamically learned MAC address already, right? Then you have to relearn it when you do the switch port security. The third method is the same as number 2, but now there's a sticky phrase, a keyword in the command simply means make it permanent. It means remember it, right? So it will store it into the not only running configuration, because running configuration will just reset after what, but you save into the safe configuration, I think. Yeah, it's the name already. Yeah, running configuration is only available during the switch on, when it's on. When you switch it off, running configuration will be lost. I think what's the other one? Saving a safe configuration or something. Anybody remember what's that?
Startup.
Yes, startup configuration. Okay, so that is it will remember this. Even if you reset your switch, it will remember that particular MAC address it learned, right? Okay. So these are example of example setting, right? Example setting that you as an administrator might configure. So from config terminal, you specify which interface you want to configure. So interface here is fast Ethernet 1. Then switch port mode access, manually configure as mode access, yeah, it's access port, right? And then switch port port security, you enable port security and then specify the attribute lah. So maximum 4 MAC address, right? And then you can put the MAC address the trusted one, right? This is one will be fixed and then the others will be learned up to maximum 4, right? And then which one you learn will be set to sticky. We will remember. Okay. And then to verify, you just type show port security interface and so on from the outside the configuration terminal, right? You can see there. Right. Okay. So another attribute is the port security aging, right? So aging simply means you can forget after a specific time, right? So that's what the aging keywords mean lah. The number or the period of time to elapse before the switch forget about the configuration, right? So you can see here two option. Absolute means the secure addresses that was learned will be deleted after the aging time you specify. Okay, you enter it lah, right? And then inactivity, if you set it inactivity, this is absolute means, okay, you provide this and you switch will follow that. After that period elapsed, then you will forget about the learn MAC address. Inactivity means if it doesn't detect any traffic for a specific period of time. If the switch doesn't detect any frames incoming from that port, then how long since the last time it received any frames, then with that, with that MAC address, then it will remove the entry. Okay. Right. So this provides convenience lah, because it's automatically done, right, by the switch rather than by the system administrator. Right. And also it can be done on per port basis for every port. Every port on the switch you can configure. Right. Okay, so this is example. The time provided is 10 minutes inactivity. This one is based on activity. So you can see interface, going to the interface you want to configure, switch port security, aging time 10, and for inactivity. Okay, if you put 10 and then the other option, absolute means after that time. No matter got activity or no activity, it will forget. Inactivity here means during the 10, you must go through the 10 minutes without activity, then it will trigger, right? Okay, so this is what happened if the switch detect the port security that you configure has been violated. Okay, the most restrictive is the shutdown, right? Shutdown, right? So you can specify like this: switch port security violation, and then what to do: shut down, restrict, or protect. Right? Okay. Let me just check something. Oh, I see. Okay. I was wondering about, sorry about the interruption. I was wondering about why there was an alarm trigger. I think there's a meeting, but I think I can view the recording. Anyway, coming back to here, these are the three options that you can specify here. You only choose one, yeah? Okay, cannot put all three. This one is all. Okay, this pipe here symbol means all. So you can put shutdown or restrict or protect. Okay, so what does it mean? Okay, shutdown, which is a default mode, right? It will transition to error disabled state, then turn off the port LED. That means there's no light anymore blinking. And then this is the alert sent to the network administrator, so the network administrator is aware what happened with that port. Syslog message sent to the syslog server, right? And it's basically an audit. Okay, it was there will be an entry in the log, right? Right. So if it's already in error disabled, means disable here means the port is shut down. So if you want to you want to activate back again to bring it up, then you have to enter shutdown and no shutdown, right? Like you have to type in sequence shutdown and no shutdown, right? Because it's actually not done by the administrator to close the port, right? You close the port or disable the port by typing no shut down, right? But it's not shut down. Well, it is shut down, but it's not done manually. So it's in error disabled state. It's down because of triggered by the security lah. But here it's mentioned as error disabled lah, right? So you have to type shutdown and no shutdown to re-enable back. Okay, that means by bypassing the error disabled state. The second option is restrict, right? So what happens is that port is going to drop any packets or any frames out basically, yeah, when with unknown source address until you provide sufficient number of secure MAC address to drop below the maximum value and increase the maximum value. Basically, if it detect some unknown address, but you still can detect the secure addresses, then it's okay, right? But if we keep on detecting source addresses without seeing the secure MAC addresses, then it start to it will trigger, right? It will trigger the security violation and generate a syslog message, just again to inform the network administrator. Okay, right? So the third one is the least restrictive protection, least secure. Just although it says they protect, right? This port will drop packets or frames with unknown MAC source address until you remove a sufficient number of secure MAC addresses to drop below maximum value or increase the maximum value. Now, basically protect similar to restrict, but there's no syslog. Okay, there's no syslog message, there's no audit lah. No syslog message sent to the syslog server, whereby the business administrator won't find out about it because it's not recorded. Okay. Right. So here's an example. We want to set to restrict, and then you type in the command switch port security violation restrict. Okay, by default it's shut down, right? So this one is restrict. Then again to verify, show port security which interface is that, and then look at violation mode, right? Restrict. Right. So the next example is when the port is shut down and is in error disabled state because it's triggered, okay, due to port violation, security violation. So that means no traffic will flow via that port. That means it's not going to receive any message or forward any message to that port, right? So you will see these messages, and this is actually the messages that will be copied and sent to the syslog server, right, for the admin to view. But it will also start showing this kind of error on the command line interface, right? You can see there. security P-secure violation error detected, and so on. Right? You'll start to generate this message. You will be able to see it on the switch command line interface, but it is also copied to the syslog server, so that will be a recorded log of what happened. Okay. Right. Right. So when it's in this state, error disabled state, when you do show interface, you will notice that you cannot ping, you cannot the port doesn't function, right? So you can troubleshoot by looking at show interface, right? So it show you down, but it's the extra information is that it will show you that the port is down, but it is in error disabled state. Okay, there's more, but output omitted here simply means we can't show all the rest of the info because limited space here, right? Okay, so show interface, and you notice that, then you want more details, show port security interface, and then the same port number, right? And then look at port status in secure shutdown, right? And then you can see that it also increment how many times the violation occurred. Okay, so it will keep track of it's like a counter, right? Every time there's a secure shutdown happen, then you enable again, it will still keep track how many times. So this one is for your own statistic, as your own information as a network administrator. Okay, and if it's happened once or twice, I think it's a way for you to to gauge whether the security violation is something serious or not. If you keep seeing security violation becoming more and more and more and more within a short period of time, then you start to you can do something about it. You can go to that computer, that host machine, and dig deeper. Why is that particular machine on that particular port having so many security violation, right? Right. So verifying port security, after configuring port security on the switch, check each of the interface on the switch to verify that port security is already correctly set, right? You can also check what's the static MAC address that's been configured, right? And you can use the command show port security, right? So it says it should show all the interfaces belonging to that switch, okay, whether it's been configured for security, right? All right, so although you can see 4 here, again, output omitted because it's going to be 24 rows, right? 1, 2, 3, 4, 5. So actually there are more, right? Right. Okay, so here, when you say show port security, it's a summary of all your ports on the switch, you can see, right? All the settings for each of the security, rather than you have to go to each individual one and show each interface. Show port security allow you to view it in a summarized form, meaning in one screen. Okay, of course you have to scroll if this long, right? F1, F2, F3, or the fast Ethernet ports, and you can see in just overall how's the security configured for each of the ports. Right. Again, here it says command show port security interface for that particular fast Ethernet interface port 18, right? And then again, you can see all the configuration in more detail, right? Here you can see the important ones, right? Configuration, but if you want to go in more detail, you can then just use this command for individual ports, right? So you can see more information, right? This one, you want to see whether it's sticky or not. That means that particular MAC address that you specify will be ensured to be remembered by that switch, right? So you can type show run. Here we use a filter, so only show, because show run will just list out a lot of info, right? So you basically filter on this lah, right? Pass Ethernet. In this example is port 19. Then it will show you, and what you're looking for the sticky aspect being remembered by the switch is this lah. Look for the sticky keyword, and then it will show you the MAC address that's been remembered. Okay, that means stick. It sticks. And basically, this sticking part is meant only if you switch off and or reset your switch, and those sticky MAC address uh, will still be remembered after you restart your switch. Okay, right. Right, so show port security address allows us to view the MAC address, okay, and the type of MAC address that is detected and remembered by the switch. All right, so you can see there two examples: secure dynamic for port 18 and secure sticky by port 19. Okay, so dynamic simply means is the switch dynamically learn about it. When it dynamically learn means if the frame ingress into the switch will check the source MAC address, determine that it's not inside yet inside the MAC address table, then it will add it into the MAC address table. So it's dynamically learn, but it's secure, right? But dynamic, if you reset, you will have to relearn that MAC address. But sticky, once it learn it, it will hit, and that becomes the secure MAC address. All right. Okay. All right, so those are all the commands that we have for securing port, right? And so the exercises involved with this will be for you to sort to not sort to add those port security, right? How to configure those port security for the ports that is attached or plugged into the host machine, right? Okay. Right. So and configure and verify. You saw the example command to use. All right. Any questions so far?
So far no.
No.
All right. So the next section we go to go is a different mitigation already. Here is about securing the ports. Yeah. And usually when we say securing the port on the switch is the access port. That means the port that we plug in from our desktop PC or desktop machine, right? Okay, so the next part is to mitigate VLAN attacks. Okay, so VLAN hopping, remember, ability to forward from one VLAN to another VLAN without using any router. All right, so before we continue with that, we have a 5 minutes break. Okay, I'm gonna go
Okay.
get
Okay.
something to drink first. All right, welcome back. Got my coffee already. Thank you. All right, so mitigating VLAN attack. Yeah, this is what we want to do. Okay, let's just see. All right. Okay, so before we continue with the configuration that we can do for VLAN mitigating VLAN attack, um, let's recap what is VLAN attack. Right, so here is indicated, and this is the attack that we want to basically mitigate. VLAN hopping attack. So hopping from one different VLAN to a different VLAN without using any router. Okay. So how does the attacker attack? Well, spoofing the uh, DTP messages, yeah, right? So, for example, the threat threat actor will use will attack from a host, okay, and the DTP messages, of course, the attacker will use what a software that can generate this DTP. These are trunking protocol messages, yeah. So pretending to be because usually another switch will generate TTP messages, but basically desired auto, right, to dynamically um, ask or request another switch to turn on trunking, right? Now, why do trunking? It's important to remember, but what is trunking? Okay, there are only two types of ports: trunking ports and access port. Access port is a port on the switch connected to a host, and a host is just one host, right? And that particular host can be configured to be belonging to a specific VLAN. Remember, a host cannot belong to more than one VLAN. Okay, a VLAN is like yeah, it's its own network, its own LAN, right? Uh, so a host cannot be member of more than one VLAN. So at the access port, we can specify that access port is belong to which VLAN. Thereby, the host that is plugged in into that port automatically belong to that particular VLAN, right? The thing is, between that port and the host, because it's a single host, single VLAN, then that means only one kind of traffic is allowed between the data and also the VoIP, right? But for that particular VLAN only, one VLAN traffic. Okay. Now we will have situation for larger networks, and of course, it only makes sense for us to actually implement this VLAN on a large local area network. Okay, because a small network, there's no point to have VLAN lah, right? But it's a small, maybe just a lab PC where even if you have 30 PCs, but in the lab or in an office, but imagine we have different offices inside the the floor of the building where we don't want to create multiple physical VLAN, but it's one LAN, right? So we have multiple VLANs. So there will be situation where the traffic is between one switch to another switch, right? So and because we don't restrict, okay, physical location of the host to indicate that it belongs to which VLAN. It could be any computer can belong to any VLAN. Therefore, if you connect the this large network via multiple switches, there will be traffic flowing from one switch to another switch. Now, when that happens, right, uh, there will be situation where hosts on one side of the switch is in the same VLAN as another host, which is on the other side of the switch. All right. So that means the link between two switches might need to carry traffic from multiple VLANs. All right. And we cannot use access port for that. Access port only allow one VLAN traffic, right? So, the default VLAN, which is VLAN 1, will be can carry by default native VLAN for any traffic that don't belong to any VLAN. But usually we have when we create VLANs, we have multiple VLANs. Maybe we name it VLAN 10, 20, 30, right? So one link between two switches might carry VLAN 10, 20, 30, and maybe a native VLAN that you have renamed from VLAN 1. Maybe also got management VLAN, right? So basically, the link between the switches need to you know to carry multiple VLAN traffic, right? Now the thing is, you need to configure that link to be trunk link. Only trunk link is able to carry multiple VLAN traffic, right? So at the trunk, the means the port that connects between the one switch to another switch has to be configured as trunk ports. And for configuring the trunk ports, you need to specify the list of VLANs that is allowed to pass through the port. Okay. Now, configuring the trunk ports, you can see that you can either do dynamic or static. Static means manual. Dynamic means you can specify either desirable or auto, right? Passive or active for the open standard. For the Cisco standard, usually is desirable or auto. So what it means by if you specify dynamic, DTP, the stands for dynamic trunking protocol. So it means they can negotiate. They send DTP messages between the ports to negotiate between them to if you got desirable or desirable auto, then trunk link will be created, right? Auto cannot, auto just waiting for message. So one of the ports should send the message. So one of them should be desirable. Now the thing is, very easily, threat actor can connect a host to the switch, and from the host part run an application that pretends to be a switch that sends DTP messages, right? So which means, if you think about it, a PC connected to a port should be access port, right? Should be access port. But what if it was not configured access port, right? So if it's not configured access port, it could be in desirable auto mode, trunk port, right? So if it's in that mode, the attacker's machine can send DTP messages to that port, and the attacker machine can just specify a desirable DTP message to it, and the port, if it's an auto or desirable port, suddenly become trunk port, and then the two will form, the attacker's machine, the threat actor machine, and the port, but it is supposed to be access port, now trunk port, will then communicate, right? So for that particular link, no longer restricted to one VLAN traffic, right? Suddenly that link can now transfer more than one VLAN traffic. So since the attacker machine is up to application layer, you can write any application, meaning to say now it is potentially can accept multiple frames from different VLANs, right? So in that way, that particular machine can access messages belonging to different VLANs, and that means again you're able to view VLAN traffic that's not meant for it, right? So you can see the attacking host cause the switch to enter trunking mode, right? Okay, so uh, uh, another option is that it can now, because it can now access different VLAN traffic, right? Then it can decide to send any message via any VLAN. The only thing it needs to do is to create the frame and tag it for the VLAN that it wants, the threat actor wants to send a message to, right? So how again, what I describe is to introduce a rogue switch. Rogue switch here is a bad switch, bad because it's under control from a threat actor, and it not necessarily to be a switch. It could be a virtual switch because it could be an application process that is running in the PC, right? In the PC. So basically sending spoof DTP messages to enable trunking, right? All right. Now that's the first kind of attack. The second attack is, again, it's still on VLAN hopping, but what you're doing is double tagging or double encapsulated. Usually a valid, um, frame on a VLAN only tag once, okay? And the switch will open up the header and get the tag, the frame tag, and the VLAN tag. Here, double tagging means even though the frame already in the header part already have one tag, okay, the attacker put another tag, right? And why do we do this? Because the attacker understand how the tagging works. So you can see here, this attack takes advantage of the hardware on most switches operate, how they operate. What do they do with the tag? Okay, right. So again, please have a look again at the last chapter on the VLAN hopping attack. Here we want to see how do we mitigate this kind of attack. What can we do? All right. So here step by step, just follow step by step. Okay. Step 1, disable dynamic trunking protocol. Okay, so that means there's no negotiation. If you want to configure trunking, you have to do it manually. That's why even in the DTP chapter, it is actually it was recommended that you do it manually, and this is the reason. Okay, because when I think this protocol when it was created, then the creator are very optimistic about the usage of the network. Okay, assuming that there will not be any threat actors, but I think it's still early stage of the networking, so quite naive lah, right? But now we know, okay, there are threat actors actively want to attack whatever vulnerabilities that you have on your network, right? So basically, even though the dynamic trunking protocol is actually very good to automate, save the tedious job for the system administrator, okay? Unless you really trust there is no access, physical access to your infrastructure device, right? Then maybe you trust that no threat actors can access any of your host and also secure environment. Then maybe, yeah, okay, you can use the TP, right? But it's safer to use manual, right? Because then even though the threat actor's computer, they try to uh, trigger the dynamic trunking protocol by faking a switch on the host, right? But since it's already configured as access mode port, okay, there's no protocol running there, DTP protocol, the DTP not running at that port, then there is no automatic trunking protocol enabled for that access port, right? Right, so step one, disable DTP on non-trunking ports. Non-trunking port is the access port. Any ports that connect to host rather than to another switch, you disable trunking protocol there. Okay, so switch port mode access. When it's mode access, there's no negotiation or whatever happening anymore. It's not listening to any DTP, okay, messages, right? So for any and all ports that is not connected to another switch port, it's connected only to host. Make sure you do this switch port mode access. Okay, this is the step one, right? Then you are the system administrator. You know which ports connect to which host and which port is actually extra, not being used. So if it's extra and not being used, disable them. Shut down those ports. And in additional security, right? Remember the parking lot VLAN? Parking lot VLAN is just you create a VLAN that is not used at all, right? Not used at all. So then after you disable additional, all those unused port, you additionally put them as belonging to that unused VLAN. You don't have to use parking lot VLAN lah, but when you go to office, nothing is being no office activities being done in the parking lot. It's just parking lot lah where you park your car. All the business activity conducted inside the building. So I think that's why they call example as parking lot. You can call them any name, but make sure that VLAN is not used at all. It's like a black hole, right? Then for unused ports, you disable, you assign them to this VLAN. So even if an attacker is able to basically plug in and somehow enable that port belongs to a VLAN that no one or no host in your organization is using. So, you know, even if they manage to on the port, right, up the port, still because of the VLAN, it don't belong to anywhere, so they basically cannot. There's no traffic inside that VLAN lah. So that's step two, right? And then for link between switches, do not rely on DTP. So you have to manually enable the trunk link. So you can control, right? You can control all the configuration for the trunk port for that trunk link. Okay, so you use switch port mode trunk. Okay, so the ports for the trunk is only between switches. Port where you plug in the link cable between two switches. Again, uh, that is better than DTP lah. If you don't trust the access to your switch, your switch, right? So you can disable DTP on trunking ports by using switch port non-negotiate. So even if someone accidentally unplug, right? Unplug the trunk and then plug one end to the machine, right? To their machine, then non-negotiate means you cannot enable it, okay, automatically by just sending the DTP, dynamic trunking protocol messages. Set native VLAN to another VLAN. You can basically create any other VLAN number, okay? Because by default, native VLAN is on VLAN 1, right? And why this important? Because of this one, the double tagging problem, okay? Please revise back. Go check back why the double tagging. Remember, it's from the host of a machine of the threat actor. Go to the switch. The switch remove the first what do you call this? The first tag, and then send over the VLAN to VLAN, right? That's located in the first tag to the second switch. The second switch saw again, and there's still a tag there. So the second switch will look at it, and then that's a different VLAN, right? Because it will be native VLAN, right? But then the second switch sees that there's a second tag. They will look at it, and maybe that VLAN is different from the first tag VLAN. So suddenly, traffic intended for one VLAN suddenly is being sent to a different VLAN because of that, because of the second tag, and then remove it and then send it to a machine belonging in a different VLAN. Thereby, you do a VLAN hopping. So it works with the native VLAN, right? So that's why don't use VLAN 1. Move your native VLAN to a different VLAN using this command, switch port trunk native VLAN, and then what VLAN number you assign to as a VLAN native VLAN. All right. Okay. All right. Okay, so we have reached 3:30. Right. So hang on now. Okay, then any question on this? I'm gonna stop my recording now.
No.
No, okay. Okay, so far, okay. So the next section is actually mitigating DHCP attack. So I'm going to start that. We're going to cover that tomorrow. Okay.
All this mitigating, is it before the attack or after the attack?
Before the attack, this
Okay.
is how you secure your network. So those kind of attack cannot happen. This is before. After the attack, basically you can't do much already. It's already happened, so they already access. There's already done all the things that they can do. They already, if they say the VLAN hopping, if they already able to VLAN hop, okay, you can then mitigate future attack, but it already happened. Okay, so you have to do this. Mitigating means to prevent lah, right? Another word to prevent. Yeah. So you want to prevent. Okay. If it's already happened, you still can do this, but just prevent the future attack. You should do this as a part of your configuration the first time before you deploy. Right. A lot of the mitigating commands that you can use is actually depend on you knowing very well about the topology and the design of your network. If you're a system administrator, you need to know, you have to plan which ports will connect to which port on the switch connect to another switch, which port connects to host, okay, and which host belong to which VLAN. So all this info you design first on paper, or you use any network design tools. Because once you already have that design, then you what do you call this? You implement all this with this in mind, all this mitigating information in mind. For example, we say for those ports that is unused, you already know, okay, which port you want to allocate to which. Okay, one of the idea is from our previous course. I think I did mention to you guys. All the cables you already labeled. It's a good practice. You label the cable. Like this one go to which host, right? So that is part of the network planning, right? So you also know which cable plug into which port, which cable belong to which host, right? You plan everything in detail. So you will also know which ports on the switch is actually unused, right? So since they're unused, don't leave them on, right? So go into the CLI, disable them, no shutdown all of them. If you are using multiple VLAN, all those unused ports, you configure those ports to use a parking lot VLAN means a VLAN that is not being used for anything, just like a black hole, right? So this involves you knowing very well about the design of the network. You have to do it as part of your network design. Security cannot be an afterthought. Security of your LAN must be part of your network design, right? So that if you do it from the beginning, I don't think you will miss out any security holes. All right. If you think about the security after the fact, right, you might forget about certain ports. You forgot how to configure it securely, right? So my advice is, if you want to implement security, you need to implement it as part of your network design from the beginning. Design it to be secure. Does that answer your question, Kelvin?
Yeah.
Yeah. Okay. All right. So we stop here for the lecture. We move on to our tutorial. I already shared you guys the tutorial. Okay. Let me just close this first. And show you where's the tutorial. Tutorial. We start with tutorial 8 first. Yeah. Security concept, right? You can take a 5 minutes break before you start on this, right? This already allocated lah. Huh? So not a lot of questions, but some of the questions I divide, like number here, number 9, what are mitigation? So let's say Kelvin answer 2, what are mitigation for that? And Farah maybe do this 2, Noel do this 2. Okay, you answer here, right? So okay, so I'll let you guys do your tutorial question. I will look at it and also will monitor any questions. I will monitor, right? You can take a 5 minutes break before you start on this, but you can also start, right? Okay, any question, just let me know. All right.
Okay.
Okay.
Oh, guys, can we meet in the next the other
Okay.
tutorial?
Okay.
Okay. See you guys there. Hello, everyone. Any
Hello.
more questions?
Tutorial
Ask
9,
question.
when to do?
Sorry, can you repeat? No,
Tutorial 9.
can you type can you type your message now? Oh, okay. So for tutorial 9, we can continue tomorrow lah. All right. Not many also, so very quickly can finish tomorrow. So never mind. You can leave tutorial 9 for tomorrow. Okay. After we finish the lecture for chapter configuring the switch security tomorrow. All right, so I think that's it for today. Yeah? If no question already, then can dismiss already. Thank you very much for your effort on tutorial. Okay, thank you.
Thank you, sir.